The foundation of biology. As Aristotle walked wandering through his great zoological garden, he became convinced that the infinite variety of life could be arranged in a continuous series in which each link would be almost indistinguishable from the next. In all respects, whether in structure or mode of life or reproduction and rearing, or sensation and feeling, there are minute gradations and progressions from the lowest organisms to the highest. At the bottom of the scale, we can scarcely divide the living from the dead. Nature makes so gradual a transition from the inanimate to the animate kingdom that the boundary lines which separate them are indistinct and doubtful. And perhaps a degree of life exists even in the inorganic. Again, many species cannot with certainty be called plants or animals. And as in these lower organisms, it is almost impossible at times to assign them to their proper genus and species, so similar are they. So in every order of life, the continuity of gradations and differences is as remarkable as the diversity of functions and forms. But in the midst of this bewildering richness of structures, certain things stand out convincingly. That life has grown steadily in complexity and in power, that intelligence has progressed in correlation with complexity of structure and mobility of form, that there has been an increasing specialization of function and a continuous centralization of physiological control. Slowly, life created for itself a nervous system and a brain, and mind moved resolutely on towards the mastery of its environment. The remarkable fact here is that with all these gradations and similarities leaping to Aristotle's eyes, he does not come to the theory of evolution. He rejects Empedocles' doctrine that all organs and organisms are a survival of the fittest, and Anaxagoras' idea that man became intelligent by using his hands for manipulation rather than for movement. Aristotle thinks, on the contrary, that man so used his hands because he had become intelligent. Indeed, Aristotle makes as many mistakes as possible for a man who is founding the science of biology. He thinks, for example, that the male element in reproduction merely stimulates and quickens. It does not occur to him, what we now know from experiments in parthenogenesis, that the essential function of the sperm is not so much to fertilize the ovum as to provide the embryo with the heritable qualities of the male parent, and so permit the offspring to be a vigorous variant, a new admixture of two ancestral lines. As human dissection was not practiced in his time, he is particularly fertile in physiological errors. He knows nothing of muscles, not even of their existence. He does not distinguish arteries from veins. He thinks the brain is an organ for cooling the blood. He believes, forgivably, that man has more sutures in the skull than women. He believes, less forgivably, that man has only 8 ribs on each side. He believes, incredibly and unforgivably, that woman has fewer teeth than man. Apparently his relations with women were of the most amicable kind. Yet he makes a greater total advance in biology than any Greek before or after him. He perceives that birds and reptiles are near allied in structure, that the monkey is in form intermediate between quadrupeds and man, and once he boldly declares that man belongs in one group of animals with the viviparous quadrupeds, are mammals. He remarks that the soul in infancy is scarcely distinguishable from the soul of animals. He makes the illuminating observation that diet often determines the mode of life. For of beasts, some are gregarious and others solitary. They live in the way which is best adapted to obtain the food of their choice. He anticipates Fontane's famous law that characters common to the genus, like eyes and ears, appear in the developing organism before characters peculiar to its species, like the formula of the teeth, or to its individual self, like the final color of the eyes. And he reaches out across 2,000 years to anticipate Spencer's generalization that individuation varies inversely as genesis, that is, that the more highly developed and specialized a species or an individual happens to be, the smaller will be the number of its offspring. He notices and explains reversion to type, the tendency of a prominent variation, like genius, to be diluted in mating and lost in successive generations. He makes many zoological observations which, temporarily rejected by later biologists, have been confirmed by modern research, of fishes that make nests, for example, and sharks that boast of a placenta. And finally, he establishes the science of embryology. He who sees things grow from their beginning, he writes, will have the finest view of them. Hippocrates, born 460 BC, greatest of Greek physicians, had given a fine example of the experimental method by breaking a hen's eggs at various stages of incubation, and had applied the results of these studies in his treatise on the origin of the child. Aristotle followed this lead and performed experiments that enabled him to give a description of the development of the chick which even today arouses the admiration of embryologists. He must have performed some novel experiments in genetics, for he disapproves the theory that the sex of the child depends on what testis supplies the reproductive fluid, by quoting a case where the right testis of the father had been tied, and yet the children had been of different sexes. He raises some very modern problems of heredity. A woman of Elis had married a Negro. Her children were all whites, but in the next generation, Negroes reappeared. Where, asks Aristotle, was the blackness hidden in the middle generation? There was but a step from such a vital and intelligent query to the epical experiments of Gregor Mendel, 1822 to 1882. Prudens quaestio dimidium scientiae. To know what to ask is already to know half. Surely, despite the errors that mar these biological works, they form the greatest monument ever raised to the science by any one man. When we consider that before Aristotle there had been, so far as we know, no biology beyond scattered observations, we perceive that this achievement alone might have sufficed for one lifetime and would have given immortality. But Aristotle had only begun.